Welcome to Diving Deeper Discussions. I'm your host, Randy Isaac, on behalf of the American Scientific Affiliation, and we are discussing articles and book reviews that are published in our ASA journal, The Perspectives on Science and Christian Faith. And today we are discussing one of the book reviews that appeared in the September 2021 issue. It is one that I actually wrote, an essay review entitled The Significance of the Mystery of Life's Origin. Now, that book happens to have an awful lot of authors, and had to pick one to do that. So why did I pick Walter? Well, if you see it, you see that the authors of the edition that we're reviewing, The Mystery of Life's Origin, The Continuing Controversy, the authors are Charles Thaxton, Walter Bradley, Roger Olson, James Tour, Stephen Meyer, Jonathan Wells, Guillermo Gonzalez, Brian Miller, and David Klinghoffer. So what this book is, being the 35th anniversary, is it commemorates and really talks about the book by that title, The Mystery of Life's Origin, the Reassessing Current Theories, that was published, I believe, in 1985 by Charles Thaxton, Walter Bradley, and Roger Olson. So that book is reprinted in this edition, as well as quite a bit of additional material. So it turns out that of those authors, Walter is the key point man in the one who kind of got the ball rolling in the beginning and started the writing and got it done. And Walter is someone that I met 16 years ago, and we've become very good friends. And we've enjoyed a lot of discussions on a variety of topics. And it is a great pleasure for me to introduce and welcome you to our program, Walter Bradley.
Thank you, Randy. Thank all of you for showing up, too. It'll be a lot more fun. Randy and I have had this conversation going for about 10 years. So it'll be fun to have some sort of new people joining us.
Yeah, it will be.
An ongoing conversation.
Just before the program, we kind of toyed with the idea of Walter would take my side and I'd take his side, and we'll see how this program goes. Maybe we'll try that some other time, but that's a bit. So, Walter, I think most of these people know you. A lot of them are from ASA, but not everyone. I think I see a few people who probably haven't known you so well. So I'd like to start by just getting to know you a little bit better, your perspectives and what's going on in your life. So, Walter, I know you're in Texas now. Are you a native Texan? Were you born and raised in Texas?
I was born in Dallas. I grew up in Corpus Christi on the coast. Went to the University of Texas for 7 years, but that was for 3 degrees, not one.
Consecutive,
7 years to get a degree in engineering.
Wow. Yeah.
I majored in material science and engineering. And,
we'll get to your education in just a bit here. So you said you moved from Dallas to Corpus Christi. So what was your faith experience growing up? I mean, were you involved in churches at all at that time, or did you come to it later? How was that?
I got my first attendance award when I was 3 months old.
That's great. And you still remember that?
I still remember that, just as a brand new baby, out of the womb for 1 month and 3 months, I guess.
Okay.
I grew up in a Christian family. Went to church, went to the church camps, and I actually became a Christian one of the years that our youth group went to church camp. So I've been involved in it for a long time. But I'll have to say that there was probably one of the holes in my experience growing up was addressing the kinds of questions that we address in ASA. And I think that we were kind of, the church kind of had the idea that just believe it and don't ask questions. Okay. And I think sometimes church with good intentions say, just take it by faith. Well, Jesus did a lot of miracles, and he didn't say just, I'm God and trust me, it's true.
Right.
No, basically. And I kind of felt like my church should have followed his example better.
Right.
It wasn't really until I got to college that I began to.
And which college was that?
University of Texas.
Why did you pick that? Just because it was close?
Because it was cheap and close.
Cheap. That's a good reason.
$50 $50 tuition per semester. And then I was in the honors program where we had only 15 students in each class. So I got kind of an Ivy League education for $50.
Not a bad deal. So why did you pick engineering? Mechanical engineering has been your calling.
Well, I loved math and I loved physics and I loved chemistry. And I wasn't sure what to do with that, but I mean, I knew what I wanted to do. I liked algebra so much the first semester that I got to have an algebra class that I asked the teacher if I could go faster because the class was going too slow. And so she said, fine. And I finished the whole course in half a semester. And,
cool.
Yeah.
That's great. Yeah. So you said previously you went on to get 3 degrees. Which ones were those?
Bachelor's, master's, and PhD.
Oh, I see. Okay. Yeah. I thought you meant in 3 different fields. Yeah.
No, not 3 different fields. Yeah.
All right. So you ended up getting your PhD in the mechanical engineering, and where did you go from there?
I went to Colorado School of Mines. They have
you broke out of Texas.
I did.
Oh my!
It was culture shock, but I got over it.
Yeah, I'll bet.
I had a good time being there. And there, while I was there, I was doing more metallurgical kinds of things. When I, after being there 8 years, left and went back to Texas A&M. I got there involved in polymers and polymeric composites, high performance composite materials for the Air Force and NASA. And so it ended up being much more interesting because it was a new emerging area.
Yeah, that's good.
So much more.
How long were you at Colorado School of Mines, and why did you leave? Where did you go?
Well, I was there for 8 years. And they said if I would wait 1 more year, I'd be promoted to full professor. I'd already been promoted to associate professor. But we felt like that we wanted to live someplace not so far from where our families were. And for me, I think it provided an opportunity, although I didn't know this at the time, to get into some areas that are material science, but new areas up and coming, rather than something that's a very mature field like metallurgy. And that ended up being providentially good.
So you went to Texas A&M, right?
Yeah, they're real. Texas and UT are big competitors. So.
Right. So it was quite a switch. And
culture shift.
Yeah, right. Did you go there as chairman of the department? I know you were chair later.
No, I wouldn't have.
Took a little while.
I wouldn't have gone if they'd offered that job.
Yeah.
And I was only kind of coerced into taking that job 17 years later. The department has 67 faculty, 1,500 students, and lots of headaches. So, so I did it for 4 years because the dean made me promise I wouldn't quit. And at the third year, I said, I'm out of here when we finish the 4th year. So.
And that's when you went to Baylor?
I was there after I stepped down as department head for probably another almost 10 years. And then we actually I took early retirement when I was 56 to do some work with Campus Crusade for Christ.
I see. I didn't know that.
Yeah. And so we did that for 2.5 years. And at the end of that time, I kind of felt like I'd accomplished what I wanted to do in that. And I wasn't sure what I was going to do next. And Baylor called up and said, would you be interested in starting a graduate program?
Oh, excellent.
And I thought I've been in secular schools, which was good in many ways, a lot of opportunity to have an influence. But it was kind of nice to be kind of my last lab, being at a Christian university where you could be Christian and be open about it and not have people complain. So. Right.
Yeah. And now I take it you're retired from Baylor and back in the Dallas area or Austin, right?
Austin area. Yeah.
Yeah. Okay. Cool. All right. Well, that's great. Well, when did you join the ASA?
I joined the ASA when I was in graduate school.
Okay.
Let's see. I'm trying to think. I would have been 22 or 23 at the time, and I'm 78 now. So yeah.
Yeah. Okay. So let's move on to the topic here a bit. And essentially, for those of you who've read the review, one of the items that intrigued me very much about the new edition is the introduction that David Klinghoffer wrote, which I think was very informative and talked a little bit about the history of how the original edition first came about. It's a good story, and Walter, I think all of us would like to hear it from you because you're the one who was the point person in getting started. So, how did this book, The Mystery of Life's Origin, really get started? What were those factors?
I think it got started when I moved to Colorado. It got started in my teaching job there and stuff, and was wanting to think of some areas where I could try to integrate my faith and my science, and to be able to have those be kind of positive interactively. And I was also interested, apart from trying to do any synthesis or integration, I had not really ever spent that much time exploring that. Like I said, I grew up in a church that really wasn't into these kinds of things, frankly. And sadly, most churches aren't. And so I think I just got to reading books and got very interested in the topic. And I was reading on all kinds of things. Some was more physics and having to do with the age of the earth and all that. I actually grew up in a church that was a young earth creationist church. But I dropped that while I was still in college. But I think initially I was doing that for my own benefit. I felt like this is a bit important area. That's just how I'm going to be earning my living. I knew that I would get lots of questions from students along the way, and I had some of my own, and so that's kind of where I got started. Initially I wasn't like, oh, I'm going to go learn something and write a book. Okay, so there was an organization that was trying to integrate sort of faith and learning in a university environment, and out of Dallas. And so they were interested in finding professors who could speak in some ways, to the integration of faith and science.
Oh, was that the group that John Buell had?
Yeah, that's the group that John Buell had. And so
what's it called? Probe Ministries,
Probe
as I recall? Okay.
Yeah.
Right.
And it was, it turned out to be a good experience because it was a good testing ground. For example, the first one they asked me to go and speak at, they would ask me what I wanted to speak on. They didn't ask me to speak on something because they didn't know what I knew something about. But it was at Colorado State University, and it was in biochemistry, a senior class of biochemistry, about 100 students. And for my talk that day, we had 5 professors come. And by this time, you have to talk on something. And I had gotten quite interested in the origin of life because one of the areas I was working in and well trained in was in polymer science. And a lot of the stuff that has to do with the origin of life, right. Very much polymers. So I went to that kind of a little bit with fear and trepidation, thinking, I wonder, I don't have all the answers to all the questions people might have, because this was not a field I'd been in for a long time. But I was pleasantly surprised at the end of my talk. I had very sort of curiosity, interesting questions from the faculty and some from the students. 5 of the faculty members stayed around to talk afterwards and said, oh, guys, because a lot of what I did was more P-Chem than biochemistry. And they were saying, well, I hated P-Chem and I never really understood. And so, but anyhow, I felt like that there were interesting things there that I had a background in and that I could explore and kind of just put some ideas out there. On some of these topics, there's not kind of final, answers, but it's an interesting area to go and say, here's where we're at. When I read the first book I read on the origin of life, I was actually quite surprised to see that it was not a Miller Urey thing. It happened maybe 15 years earlier, but there was an awful lot of mystery
Mm-hmm.
And everybody understood that at the time. Nobody pretended we know how life began. The Miller-Urey experiments
Right.
were kind of
Mm-hmm.
a very interesting but not big step, in my
Mm-hmm.
opinion. And
Yeah. Okay. So that's kind of how you got into more faith and science issues. And so this group asked you to write this book. Is that how it worked?
it was not my idea. And when they first asked me if I would, they were trying to find more people that could write books, kind of integrating faith and learning, not just
Mm-hmm.
in science areas, but in other areas too, but ones that were uh, maybe suitable for faculty and students, but in some cases they might just be for a general audience.
Mm-hmm.
Depends on the topic.
Okay.
Yeah.
So you pursued that, and how did you come to incorporate your co-authors?
Um, let's see. I think as I told them, first of all, I wasn't interested in writing a book on evolution, which is kind of the topic people normally think of when they think of faith science conflicts. That I didn't know anything about. I didn't have a background in biology. I had a really good background in physical chemistry and polymer science and stuff.
Mm-hmm.
But so when I decided to take that on, I said, I don't know if I can write a book. I'm just going to see where the field's at.
Mm-hmm.
There wasn't any assurance that it was an area where there was interesting stuff to write
Right.
about and make a book.
Yep.
So yeah, but the after I got down the road, there were some things, some areas in the subject area that I felt like that I didn't have as good of a background in biochemistry as I would like. I had a really good background in physical chemistry and polymer science and engineering, but not as much on biochemistry. And so that's where I asked Charlie
Mm-hmm.
to
Charlie Thaxton.
join me. Yeah, Thaxton. He had a PhD from Iowa State and had postdoc at Harvard, and he was quite interested in the topic too, and our backgrounds kind of complemented. And then Roger Olson was a PhD student there who is a Christian, nice guy. Who
at Colorado School of Mines, right?
Colorado School of Mines.
Yeah.
Yeah, and he. We had some questions about what was the early Earth's atmosphere. There were a bunch of questions like that,
right?
That I think were sort of in flux. That
right.
was the field that was active, but it was still kind of sorting things out. And Roger had taken courses and maybe even done some research in that area. So I felt like rather than trying to pretend I know something about that, it would be much better to have somebody who really knows something about it to do it. And so, and being a good friend, he was happy to do it, and he did a really good job. So.
Wow, the result was quite successful here. I know we're eager to get on to the discussion and open it up to the audience, but before we do, just a few more comments over here. First of all, as many of you have read, is that the title of the review I wrote is The Significance of the Mystery of Life's Origin. And I think you probably all realize that there was a bit of a double meaning to that. One thing, which is very much the focus of the 35th anniversary edition here, is the significance of the book. What impact did it have and where was it? And it's very helpful in terms of the introduction, how it got started, as well as what the effects have been. And we'd like to get into that a little bit more. But the other meaning there that I wanted to pursue also is, what is the significance of the fact that life's origin is a mystery? So those are the two different aspects of the title that we want to dig into a little bit. So one of the basic points of the 35th anniversary edition is that the original edition of the book was really the foundation for the future of the intelligent design movement. But do you really talk about intelligent design in the book, or that came later? Or how do you see that your book really, I mean, that's not something you intended, right? It was a natural outgrowth of what you wrote. how do you see the impact of your book is really what I'm asking, I think.
Well, I think that it was published in 84. Mm-hmm. I think at that point in time, I don't think the term had even been attached to faith and science working in the biological areas. I'm not quite sure when that happened. That probably happened maybe 8 or 10 years later. And I think it was that title, Intelligent Design, was probably coined by, I'm having a senior moment here, the law professor from Berkeley. Come on, some of you guys must know who.
Oh, Philip Johnson.
Philip Johnson, yeah. I think Philip Johnson was probably the one that first coined that term. And
okay, so what do you think it is that was in your book that made it that foundation in your perspective?
I'm not. I don't have a good sense of what, if any, impact it had on what I consider to be the rest of the story. Okay, at least not directly, maybe in some general sense, but I think that the fact that the book could be written and taken seriously probably was more important than any detail. It didn't have any specific things about evolution. Okay. Right. And that's because I don't know anything. I would not write a book and claim anything about evolution one way or the other, because I really am not qualified to do that. But I think that I went to Gordon research conferences. If some of you have some background in chemistry, you know what those are. Had a chance to meet a lot of the people who were active in the field and have conversations with them. When our book came out, I went to another Origins. Just one thing, real quick, Randy. I asked 6 people there. I asked more than 6, but I had 7 people who said they had read the book, and in each case, I said, "Well, what did you think about it?" And in 6 of the cases, the people said they thought it was really quite interesting and didn't have any great criticisms. The 7th guy, though, said he didn't like the book at all. And he happened to be the editor of the main journal, Origin of Life and Evolution of the Biosphere. And I said, "Well, what didn't you like about it?" And he said, "It was too damn good to be a creationist book."
There you go.
And I took that as a compliment.
Well, I'd like to start the discussion here. I usually start with the written questions ahead of time, but I'd like to pursue this point a little bit more. And I see a number of your co-authors that have joined. I'm delighted to see them here. And I'd like to ask them this question. Becky, I'd like to go ahead and open up the microphone so that people can unmute themselves now. So that's a possibility. But please, I'd like to ask everyone, keep yourselves muted unless I call on you to speak. And I would like you to raise your hand if you have something to say. But there are a number of you who are co-authors. And I'd like to ask you the question then, particularly of this edition. What is it about the first edition that you think really enabled the foundation, or caused it to be the foundation and enabled the rise of intelligent design? Walter's not quite sure. So let's see. Where are you? If you can raise your hand, one of you co-authors would like to say, comment on that. Or Walter, you can pick one. You can see the list here, right?
Steve Meyer has his hand up.
Steve Meyer does. Where are you, Steve? Okay, Steve, unmute yourself. Let's hear from you. Let's see. You're.
I'm unmuting. How's that?
All right. That's fantastic. Good to see you, Steve. Great to have you here.
Handle the technology, and then everything else goes great.
Yeah.
I actually know a bit more of the story because I read Mystery in '85, met Charlie Thaxton and Walter at a conference in February of '85. I was in Dallas at the time and spent a lot of time with Charles Thaxton discussing the book. In the epilogue to the book, they float the idea that the information-bearing properties of DNA are an indicator of a prior, as they put it, intelligent cause. They didn't use the word intelligent design, but they said intelligent cause.
Yeah.
And I was intrigued with this idea, but not fully persuaded at the time. A year later, I was off to grad school, and I did a PhD in Cambridge on origin of life biology. And all the while, I was thinking about whether or not a positive argument for an intelligent cause, or what we later called the idea of intelligent design, could be made. There was a conference in '88, I see, in Seattle called Sources of Information Content in DNA that Charles Thaxton convened. Dave Wilcox, I think, was at that conference, and a number of other ASA guys. And it was at that conference where I think Charlie came up with the term intelligent design. Phil Johnson was not really promoting intelligent design when he got into this. He was mainly making a critique of Darwinism. So intelligent design was not really his concept. And the term intelligent design was chosen or used because it made clear what it was that the proponents of the idea were not only affirming but opposing. Richard Dawkins, 1986, wrote The Blind Watchmaker. On the first page of the book, he says, biology is the study of complicated things that give the appearance of having been designed for a purpose. And basic Darwinism back to the 1850s and 60s was the idea that yes, things look as though they were designed, but there's an unguided, undirected process, namely natural selection, that can produce that appearance without being guided or directed in any way. So we wanted to make clear we weren't challenging the age of the Earth. We weren't challenging microevolutionary processes. We weren't necessarily challenging common descent, but we were challenging the idea that the appearance of design in living systems was merely an appearance and was not the product of an actual designing intelligence, which was central to the whole Darwinian perspective. And so that was sort of the origin of it. By the end of my graduate year in 1990, I'd met Bill Dembski. Well, actually, I met Dembski the year after I got out of grad school. I met Doug Axe, who was finishing at Caltech in late 90 when I went back to do my PhD examination in Cambridge. And Paul Nelson I met at the 1988 conference. And a lot of us who were finishing PhDs at the time were really inspired by two books. Denton's book, Evolution, a Theory in Crisis, which developed in the 13th chapter, a very interesting, positive argument for intelligent design, or the design hypothesis, as he called it. And the exploration of the idea that had been floated in the epilogue to Mystery of Life's Origin, that the information-bearing properties of living systems were a positive indicator of the activity of intelligence and allowed the activity of intelligence to be detected scientifically. And I think that was the key idea in mystery that intrigued me, and that Dembski and I and Nelson and Axe and others started to develop in more detail in the start of the early 90s. So I think that's the origin of this heretical idea.
Yeah, so that's very helpful, Steve. Thank you. So it's basically in the epilogue that I believe Charlie Thaxton penned, right? And it was that concept. Okay, so that is the core, and it's not so much the scientific critique, or the status of the origin of life, but this notion that it must have been the information. Okay?
Well, Randy, the two things go hand in hand in a way, because as I began to study one of the other key ideas in mystery was the idea that there are different methods of scientific reasoning. There's what Walter and Charlie called operation science, and what they called origin science. I thought that terminology was cumbersome, and I adjusted it a little bit, but my PhD thesis was basically inspired by that distinction. And I argued in my PhD thesis there was a distinctive method of historical scientific reasoning and interestingly, it was used by Charles Darwin, and he built on ideas that he'd gotten from Charles Lyell in geology. And there's a method of reasoning used in these historical sciences known as the method of multiple competing hypotheses or inference to the best explanation. And it requires necessarily comparing competing explanations, especially with respect to their ability to provide a causally adequate account of the facts that we have at hand. And so the critique in mystery is one side of a multifaceted evaluation of the evidence. If one sort of hypothesis is inadequate, if it lacks causal adequacy, and another hypothesis has causal adequacy based on our uniform and repeated experience, the maxim from Charles Lyell, then you can draw an inference to a best or better explanation. So the critique and the positive case in all cases go hand in hand in this type of reasoning. So, so what they did in mystery was important in both senses, because it showed that we were in fact at a point of impasse with respect to chemical evolutionary accounts of the origin of life. But there were features of life that also suggested an intelligent cause based on our uniform and repeated experience of what it takes to generate, for example, information or a functionally integrated system.
Right. Okay. This is very helpful. Yeah. So basically, it seems that you were the channel then that kind of took the ideas from the epilogue in the book and the book as a whole, and that really stimulated your interest in the field, and it shaped what your thesis was on and shaped the direction. And in that sense, you're saying this really was the foundation that helped you and your colleagues get going on the intelligent design.
It was the spark, the catalyst. Yeah.
Okay, that's great. Any of the other co-authors want to say anything? I don't see. Feel free, or will you want to leave it there? I want to make sure you get enough time to comment a little bit. Okay, so Sai, you got your hand up, but is it on this point, or I wanted to do the early initial submissions first? Brian, you're one of the co-authors, so you get a little preference over here. Brian?
Thank you. I think one thing that's really been interesting in the development of the science over the last several decades is what's happened as engineers have worked with biologists to study life. So what you're seeing in life now is not just simply generic evidence of design, but the same engineering principles, the same motifs. And what's fascinating with the origin of life is when you look at people who studied minimally complex self-replicating robots or space probes or von Neumann's work, and you compare that with studies of minimally complex cells, there's this extraordinary overlap. So you can actually predict from an engineering perspective what will be the components of a minimally complex cell and what will be the functional interrelationships. So what happens is bringing this design perspective into the study of biology is creating enormous fruits in terms of explanatory and predictive power. And that's what I find so exciting, is how that science has developed over the last several years.
Okay, very good. Thank you, Brian. Okay, Sai, we'll get to you in just a minute, but first, dibs go to David Singer, who submitted a written question here. And we'll open it up for discussion. Again, any of you who'd have something to say, click on reactions and click on raise hand, and I'll call on you shortly. But Dave Singer, go ahead and ask your question. Unmute yourself, please. You got to unmute yourself here. You got it there, right? I can't unmute you. You have to do that yourself. Sorry. Zoom has now written that you can't unmute others. You're having trouble unmuting yourself, then we'll have to come back to you a little bit later. Huh? There you go. All right. We got it. Go ahead.
Well, it's interesting to me that in this whole discussion, it seems to me that intelligence. First of all, you have the coding system that the genome represents. that itself shows an intelligence. You have the same thing with the standard model in physics that shows it's a very elaborate intelligence. And just the activity of science itself and human intelligence, all of these things seem to me point to something outside of the system.
Want to comment on that, Walter?
I completely agree. The analogies are so compelling in a way when you look at how amazing nature is in so many of its functions and stuff. And I look at some of these things and say, boy, I wish I had been clever enough to think of some things like this, that I could get designed to sell, because this is really good stuff. But I think it is, I think maybe engineers notice that more than biologists. I don't know. But because they take it for granted, but then they take a lot of things for granted, like, a lot of the machines we have and all, and they're kind of like their details aren't interesting. You just want to push the button and have it work. But we like to see why it works or how it works. Nature ends up having those.
It seems to me, Dave, that probably everybody on this call here agrees there is an intelligent designer. I mean, that's kind of core to our Christian faith. God is a creator. He is intelligent. He created everything. He designed it all. So we have a lot in common. And like Dick Bube wrote here, we believe in creation. All of us have this as a factor of unity and common belief. And we can see that, as Romans 1 says, we can see it in all of creation. And I think we all agree on that. And so when you say you see intelligence in these, I'd say absolutely. However, when you add that word external, it's a question of what do you mean by that? Yes, God is external to that. So in that sense, we all agree. But it seems that this terminology that you use could also be interpreted in a different sense, in a more particular sense, that says that this intelligence and the intelligent design action is made manifest in a way that cannot be described through whatever you might call it, laws of nature or naturalistic means. Okay. Now, that is where I would raise a little bit of a distinction, because to me, that part doesn't follow. Because as you said, everything about the genetic code, the genome, the structure, the hierarchy, I mean, it's fabulous. It induces a sense of awe and wonder and a conviction that there is an external intelligent designer here. That does not follow, however, in my opinion, that that means that it wasn't designed through some process that we can understand. To me, we don't know. Okay, I don't know that there is such a process. I don't know that there isn't. But I'm saying the items that you expressed certainly lead us to intelligent designer, but not exactly in terms of what that means in detail. So, Sai, you have a question? We can continue, get back to this shortly. Sai?
Well, we see Steve raising his hand, so you may want to go to him first.
Okay, well, go ahead. Go ahead. We'll get back to him. He'll have time.
Okay, so I wanted to say something about your first question, Randy, about the significance of the mystery, and it also relates to the comment you just made now. And I think it's a very good question to ask, why is there a mystery about the origin of life? And we could compare it to something like Darwinian evolution, or at least a theory of evolution. We have a theory of biological evolution, and that theory has lots of evidence supporting it. We do not have a theory for the origin of life. There is no actual clear scientific theory for the origin of life. There have been many ideas proposed. Most of them have ended up not going very far. More recently, the RNA world hypothesis has gotten into a lot of trouble. It's been modified quite a bit as an example. So that's very strange. Why do we not have a theory that we can, use and make progress with, as we've done with evolution, for example? And evolution is not finished. There's still a lot more examples to come. And I think the reason is because standard biological approaches to the question of the origin of life are not going to work. They haven't worked, and they probably won't, unless we make some major paradigm shifts, this is my own opinion, on what we include. And I think the comment Brian made just before about, ID having provided some valuable insights into the issues of the origin of life and biology in general is applicable here. The whole idea of irreducible complexity was something that stimulated a lot of work by evolutionary biologists and resulted in some progress. So I think that that's true. And I think that when we get to the origin of life, we have to recognize, as I think almost everyone does, that origin of life is not part of the biological theory of evolution. The two things are separate. Right. And for the origin of life, we are probably going to need some concepts that have been prohibited in biological research for a long time, since my career began. And we may need to revisit those. And there are even non-Christian, very well-known non-Christian biologists who are making the suggestions, such as Dennis Noble and James Shapiro and others, that we need to incorporate things like agency and teleology, because they are in biology, and to ignore them and deny them is not helping. And I think that that's why this mystery of the origin of life is so significant. There should not be a mystery.
I would say those are some interesting issues, and I hope we have a good article in the journal that we can discuss in the future and dig into that in particular. And just to add a problem to the mix that you talk about, we're kind of stuck at the beginning because we don't really know how to define life itself. And how can we talk about the origin of something when we can't really get a firm handle? We've been trying to define it. I mean, Schrodinger put his oar in the water and with a seminal book way back, but it's never been really something we can crystallize. So how can we talk about the origin of something that we don't really understand what it is? Brian, did you want to comment on? Oh, Steve, I hear you had your hand up first. You don't have your raised hand, but go ahead. Unmute yourself. Unmute.
Yeah, I figured out how to unmute, but not how to make two little yellow hands pop up. Sorry about that.
Oh, okay. All right.
I really liked what Isai just said in his first comment as well about the whole coding system that's evident within the gene expression system of even the simplest living cells on Earth. And Randy, you're doing such a good job moderating the discussion, but you also were you wrote this, the critique, and I thought maybe it'd be good to get into some of the points you wrote in your critique just to keep the discussion moving forward in a real focused way, because I think the locus of our disagreement has to do with this precisely this issue of coding. You wrote that the DNA is not encoded in an abstract code, but a code embodied in a biomolecular system. And I thought that was a somewhat imprecise formulation, that sentence, but it was the essence of your critique. That yes, you said DNA has complex specified information, but it doesn't have a particular kind of complex specified information that would indicate intelligence, namely a kind that encoded in abstract code. I think a more precise formulation or description of what's going on in DNA is that there's information that is either encoded or expressed via an abstract symbol convention. And in other words, DNA has exactly the property you're looking for in a design system. And this goes back to the sequence hypothesis of Crick in 1957, 1958, where he realized that the nucleotide bases in DNA are functioning just like alphabetic characters in a written language or digital characters in the section of machine code, which is to say that they are not conveying information in virtue of their physical properties or their chemical properties, but rather they're conveying information in virtue of their precise arrangement in accord with an abstract symbol convention, which was something he predicted existed and was later elucidated by the molecular biological revolution of the next 7 or 8 years. And that is what we now call the genetic code. And if you look at both the sequence specificity of the genetic text and the way in which the genetic code is physically instantiated, both of those systems are physically and chemically arbitrary. There's nothing about the chemistry of the nucleotide bases that determines their sequencing. And there's no physical or chemical interaction between the nucleotide triplets on one side of the tRNA molecule and the acceptor arm on the other end where the amino acids attach. It's a purely abstract, in the sense of physically and chemically arbitrary assignment that allows the information to be transmitted to build from nucleotides a completely different type of physical system, namely amino acids and amino acid-based proteins. So I think what you're asking for is evidence of a decisive indicator of design is precisely embodied in the gene expression system and in the genetic code. What else could be meant by abstract other than physically and chemically arbitrary? But that's exactly.
I'm glad you asked that. That's precisely
a true code. You acknowledge that it's a true code, but what do we mean by true code other than it's the assignments are physically and chemically arbitrary? They're not physically determined. And this goes back to a point that Polanyi made way back in the late 60s in his seminal work, Life Transcending Physics and Chemistry.
Mm-hmm. Yeah, this is great, Steve, and we can continue our discussion. You may recall that more than 10 years ago, we started this discussion privately after you and I met at the Vibrant Dance Conference, and we had a continuing private phone call afterwards. And
I think we did Vibrantly Dance. That was
yeah, it did. It was quite a group over there, and we ended our conversation in February of 2011 when you exclaimed, "I'm sure there's something abstract in there somewhere." And I'm glad to hear that you've articulated where you think it is. And I too have been thinking about this for 10 years and trying to articulate this. And I would differ with you on this point that the code is in any way abstract. And I would particularly, what I tried to articulate here is how do we know whether there's something abstract or not? Because what made it so difficult is that codes can be in a physical embodiment. They can be in an entirely abstract kind of world, and you can create a physical machine that can imitate an abstract series. You can do all sorts of things. So what I wrestled with for many, many years was how can you really know whether this is a physically embodied code or is it an abstract one? What is the real thing? And what I finally decided is that what I would propose here is that the key is to understand on what basis is it possible to decide whether a particular informational sequence is specified or not. I mean, you were very good in your book, Signature on the Cell, of defining the complex specified information and that's the implications of it. But the question really is, what makes complex information specified or not? How do you determine that? And the question I felt you never have addressed yet is on what basis can that be universal? Now, what you're saying now is, well, just the existence of the code, which, all right, let's get back to that. So let me first say is that when you look at whether or not something is specified, in virtually all the examples that you give, from telephone numbers, from language, the alphabet, and all of that, when you decide that it's specified, it's based on some abstract relationship. And so it's not the implementation of the code. It's because you can do that in any physical mode you want to, looking at the letters. However, what is going to determine whether these letters are in a meaningful sequence and that they are in the sequence that conveys the correct message? That's an abstract relationship. And intelligence has to be there to make that kind of relationship. Now, when you look at the genetic code in the cell, what is it that determines whether that genomic sequence is specified or not? Is it correctly specified? And the answer to that is, and you could do it at every level, the cellular level, the organ level, the whole organism level. But ultimately, the decision is it correctly specified is whether the organism can survive and reproduce. And that is not an abstract function. Now, you can have abstraction along the way all you want to.
Randy, you're confused.
Just a minute. Let me finish.
You're confusing a whole bunch of different concepts in the way you're speaking.
Well, I would say you're confusing a lot of them, because when you're calling abstract the sequence from the genetic code through the translation, these are not abstract relationships. Now, you're saying that, it's abstract because it could be anything. No, it can't be anything. It can be only that sequence of steps that leads to the final result. Okay, so it's not, there's more than one that could happen. And those steps aren't necessarily dictated by a chemical relationship. But which of these sequences, which of the configurations, which is it that's really going to succeed? That is determined by whether or not the organism survives. And that is the core determination. And that is not an abstract kind of relationship. That's a physical one. Nature can know that.
It's a functional
nature
requirement.
Knows the information.
That's
It's a functional requirement. Precisely.
Functional requirement is one way of expressing the notion of specification.
Exactly. And you spell that out very well. We have a very
precise definition of what we mean by specification, specified. And in biology, that's determined by function. But that's that we use the same type of conceptual, the same type of concept to determine specification in the use of human language or computer code. There's no confusion here on our part. And you want to say that because something has a physical embodiment, that it can't therefore be expressing an abstract relationship. But I can pull off my shelf a dictionary, which is a physical embodiment of an abstract symbol convention that we use in English. We use the ASCII code can be written down in a physical form. That is a physical embodiment of a set of abstract relationships. By abstract, we mean precisely things that are not physically and chemically determined, but that are assigned arbitrarily with perfect physical and chemical freedom. So the genetic code has the same precise property as codes that we use in other realms that you recognize as having as expressing abstract thought. So I don't think there's a conceptual difference here. I think there's a precise isomorphic mapping, and the same thing applies to the text itself. You have the code and you have the text. The text is also physically and chemically indeterminate. If you look at the nucleotide bases and the way they attach to the DNA molecule, there are no physical chemical. There's no stereochemical connections between the bases along the message-bearing spine of the DNA molecule, and each one of the nucleotide bases attaches to the sugar phosphate backbone with the same type of N-glycosidic bond, which allows perfect chemical freedom for any one of the bases to attach at any one of the sites, which is one of the reasons that the whole self-organizational program has failed in the origin of life research, because there is no physical or chemical explanation for the information that the molecule possesses. And in looking at the case for design, we've looked at necessity, physical, chemical, self-organization, chance type explanations, things that attempt to combine the two. And all of those fail for fundamental conceptual reasons. And what's left is what we know from experience, is that it takes intelligence to generate information. So there is information in DNA. Nobody doubts that. And it does have it does express an abstract symbol convention.
Well, okay. So this is good. So we can understand here what we're saying. Oh boy, so many things. How shall I start? Yes, there's information, but there's no universal law if you look at what really connects intelligence and information. And
What does that mean?
the
Randy?
whole sequence.
What does that mean? What does
Well,
that mean? There's no universal
one of the questions. Well, you're saying that all you're well known in all your talks and of saying that all the examples that we know, information requires an intelligent being, and I'm paraphrasing very shortly here because I have time. And then you say, therefore, the genetic information requires intelligence as well. And I'm short-circuiting a lot of your arguments. So that basically implies a universality here, that complex specified information, wherever we find it, requires an intelligent being. And the question needs to be asked a little bit, okay, what is the basis for that universality? Why should it be? It's not really in the information itself. It doesn't have that character there. The complexity isn't it. It's in the specification, with which you agree. Okay, so the specification is very much the functional part, as you said, but I would differ with you in this sense that is the function correct? I can build, my career was in computer chips. I can build an arithmetic logic unit that does the basic arithmetic. If I design and build that unit and I do the testing and it tells me that 2 + 2 is 5, it performs its function perfectly. It does exactly what I designed. It does exactly what I built. It does it perfectly. So the answer should be correct, right? No. Because why? Because I know from an abstract relationship point of view that is not the correct function. So there's another level. You can't just say something functions physically. It needs to have a specific determinant of what determines whether it's correct. And so you saying that there's no stereochemical kind of sequence that determines where things are. That's correct. The sequence is determined that it is correct, not because of any kind of chemical relationships, but whether or not in the end, the organism survives. In the end, does the organism reproduce? This is the core criteria. That's the definition of function. That is not an abstract relationship. And I see no abstract relationship. The
Randy,
items
you're conflating different things. That you're equivocating, because the abstraction is in the relationship between the input and the output, the nucleotide sequence and the amino acid. There's no necessary physical chemical pathway that produces that apart from the arbitrary code that assigns meaning or function to one type of sequence as opposed to another. Yes, there is a physical outcome of that in the same way that there's a physical, if I shout fire in a crowded theater and there really is a fire and people get out, that aids function, that aids survival. That's a physical, but that doesn't mean that my use of code of English was not based on an abstract symbol convention. So you've just conflated two different things. The fact that there's a physical outcome of survival for an organism doesn't mean that the gene expression system, which is expressing information in a sophisticated way, it's a sophisticated information storage, transmission, and processing system, that aids in the survival of the organism does not mean that system does not express an abstract symbol convention.
Okay, so that's
abstract symbol convention. Thank you. In the genetic code.
Thank you, because I think that
meets your own criterion of design as articulated in your critique of our book.
Well, thank you, because I think I see where, in my opinion, you have a fundamental error here, because the sequence, if you're talking about the sequence from the genetic code to the intermediary tRNA and the whole process that does it, you're saying that isn't a necessary piece because there is nothing that dictates physically or chemistry that it must be in that particular sequence. On the other hand,
or the different assignments that are involved in the code.
There are different assignments. Right.
17 different genetic codes now showing that the code that's the dominant code is not physically and chemically necessary.
Absolutely, but that's redundancy. I think you're conflating redundancy here and abstraction. It's not an abstraction that says this piece will work. Nobody's saying abstractly that you have to have this. What happens is which
Andy,
one
what
works.
do you mean by abstraction? What do you mean by abstraction?
Abstract is something that is not determined in a physical relationship.
That's what I mean by abstraction, and that's what you have in the gene expression system.
The entire gene, you could follow. Any biochemist will show you the biochemical flow of what happens from one to another. So you're not saying that part. You're saying why does this particular codon, lead to a particular amino acid? And I'm saying, yeah, because it works. This is the reason. It's not because you need some abstract kind of source here. There's no basis for that. And I think you're extrapolating that kind of code requires an abstract source. And it doesn't.
That's not what we're saying. We're saying that the absence of a physical chemical basis for the code and an absence of the physical chemical basis for the precise sequencing that constitutes the information is evidence of abstract thought, of cognition, of intelligence. And you asked a minute ago, well, what is it that suggests intelligence? It's precisely the extreme improbability that defies chance and the absence of an underlying physical chemical basis for coding.
Yeah, and
which is what you just described as abstraction. So
I think that's a fundamental misunderstanding here, or difference here, that we could agree. We can talk about this further, but no, that is not necessary for that kind of genetic sequence to exist. But let's give a few other people a change, and we can come back to this. All right, Brian, you've had your hand up for a long time. Let's give you a chance.
Yeah. Thank you. Thank you for inviting me. Also, is one thing that's helpful to recognize is there's a difference between the design by laws of nature and then engineering design, because engineering design, as you well know, represents a pattern, a blueprint that's imposed upon matter. So when you look at your computer chip, never expect some natural laws to be determined or found that can cause a computer chip to form that'll run a calculator or a space shuttle. In the same way, when you look at life, you look at studies of a minimal complex cell, you see arrangements of molecules that are conforming to a blueprint, a control system, a design logic that engineers can identify. So Steve's example of the DNA code or the translation system is simply one example of when you look at the minimal components of life, you have engineering constraints where molecules have to be put into an arrangement that transcends their physical and chemical properties. That's why it's not even logical to expect there to be ever a natural process that could produce a cell, because a cell is not defined by the chemistry and the physics, but by these engineering principles that are imposed upon it. And that's really striking, because I think an analogy would be like the movie Contact. When Jodie Foster saw this signal in space, which was the schematic of a spaceship, no one would ever assume that was produced by, let's say, self-replicating robot or quasars that were being selected for spaceship signals. It showed an engineering pattern imposed upon nature for a goal. And engineers have no problem recognizing in life abstract patterns, control systems, feedback loops, information processing, energy production. And they recognize that these systems have goals and purposes. So this positive evidence of now is really being recognized more and more biologists. And they even will say that we have to assume life is designed to make progress by applying engineering principles to see the goals that are being implemented. And that's, I think, a very important distinction, because I would argue we're really seeing this debate that goes back to Aristotle and Plato versus Democritus of atomism or materialism versus teleology, how the pendulum is shifting, and the origin of life in many ways is the center place where that shift is happening. Even people like Paul Davies have said that there are no physical principles in the universe that can cause life to form. He and like Sarah Walker is saying that life represents, you have to look at it from this very top-down design or goal orientation. So I think that's really, really exciting about where we are in the field.
Okay, thank you very much, Brian. I appreciate that. I would only observe that, at least from a physicist point of view, if we get out of the biology, that there are examples, spin glasses and various other kinds of things where configurations can be obtained that are not determined by their direct physical chemical correlation. So, but we can get into that a little bit later. So thank you very much for your comment. Larry.
Yeah, I would like to ask the intelligent design people among us whether they are contending that it is impossible that the origin of life could have come about through process.
I could answer that if you like. I just helped to write the chapter on that. When you look at, if you take any basic chemistry book, you ask, well, what's spontaneous process? They'll tell you if you're at constant temperature pressure, spontaneous processes always go from high free energy to low free energy. They either higher entropy to lower energy or both. But the origin of life requires a chemical system to go to both low entropy and to high energy. And that basically goes against all the known laws of physics and chemistry. And if you look at people like Jeremy England, who've tried to argue that maybe there's these self-organizing processes where you can have an energy that causes the system to match it. If you look at all the experiments, it only works if the scientists very meticulously engineer the system to create this right energy matching. So if you look at, let's say, all origin of life research into this, people like Michael Russell or Nick Lane, what they're desperately trying to do is figure out how can you get a chemical system to go to a higher free energy. So they're looking at natural engines like proton flows, events. They're looking at maybe seismic waves. Problem is there's no matching between the raw energy available in the early Earth and any chemical process in a cell. So what you find is adding raw energy to any chemical system will always move it away from life, not towards it. So for all practical purposes, arguing for natural origin of life is kind of like arguing for a perpetual motion machine. You have to assume nature to do the opposite of what all research suggests that it should. In addition to that, people talk about like self-organization or reproduction, but you can't have reduction. You cannot have natural selection until a vast array of machinery is in place and properly interconnected. And the evidence of foresight, coordination, goal direction, energy production, information processing, the list goes on, points to design as clearly as the signal from space in the movie Contact. So that's kind of what I argued.
So essentially you're saying that it couldn't have happened through process, and you're arguing on the basis of thermodynamics.
That's one argument, Larry.
Yes.
I would add to that when we look at the information that's present in DNA and RNA, that trying to explain information by reference to an underlying physical or chemical law is incoherent, because laws of nature by definition describe redundant or orderly patterns where you have a repetition of the same thing over and over again, which is why we can describe things with a differential equation or an algorithm. But information is irreducible to that type of repetition. We call it in information sciences, that's known as redundancy. What we have in the genetic code, in the coding regions of the DNA, the other functional regions of DNA, the non-coding regions that we're now discovering are functional and not junk, are aperiodic sequences that are nevertheless specified by independent functional requirements. And that type of information has a property known as complexity, which is irreducible to redundancy, and yet the laws of nature are by definition redundant patterns of order. And so trying to explain the origin of the information necessary to produce life by an underlying algorithm or law-like process, I think is conceptually incoherent.
So again, you're essentially saying that on the basis of what we know at this point, you're saying that it could not have happened through process. It could not have happened through a physical process.
Well, my overall argument is a bit more nuanced than that, because going back to Jacques Monod, I look at both necessity-based, that is self-organizational or law-like explanations, but also chance-based explanations. Remember, his famous book had the title Chance and Necessity, and explanations that combine the two, some sort of prebiotic natural selection, which is what the RNA world attempted to revive. But I show for different reasons that each of those are inadequate. and that there's a fourth fundamental type of explanation that needs to be considered, and that is an appeal to agency or mind or engineering, and that we have indicators of precisely effects that only there are effects in the cell or indicators in the cell that in our uniform and repeated experience are only produced by agents. And whereas these other modes of explanation, chance, necessity, or the combination of the two, are causally inadequate for both empirical or theoretical reasons or both, agency is known to produce the type of effects we see: information processing, that curious conjunction that Brian just described between a low entropy state and a high energy state. That is a combination of features that we only find in design systems. So we're not making an absolute impossibility argument. We're arguing for design as the best explanation, given what we know from this variety of fields that are relevant to trying to understand the origin of life.
Could not design have been accomplished, however, through process?
Not through a process which is law-like, because the kind of the evidence of design that we have is aperiodic complexity. This goes back to, as Randy pointed out, the great book by Schrodinger in 1944, What is Life? He said it's an aperiodic crystal. It's something that has specificity, but it's not repetitive. Law-like processes are repetitive by definition. That's why we write laws. We have all unsuspended bodies fall, and they do it every single time. You have the same type of effect recurring over and over again. Same input, same output. That type of pattern is not an informational pattern, but a redundant pattern from the standpoint of Shannon and other information sciences. So,
but perhaps we've not yet discovered the processes through which it could have occurred. For example, there's extensive research now going on regarding the interaction between RNA and proteins, and the possibility exists that we have not yet discovered the relationship that was necessary to lead to the code.
Well, that's right. You can always
transfer RNA. We don't understand exactly how tRNA could be involved, and yet there's extensive research into that very essential aspect of the RNA, DNA, and protein phenomenon. What I'm saying is, perhaps our problem is the science hasn't yet gotten to the point where we can understand how the DNA, RNA, and the coding system came into existence.
Well, that's a reasonable thing to say, but let me give you another cut on that. Perhaps the problem is that our science has excessively narrowed the explanatory possibilities, because I think nature's talking back. The RNA world was a real hot thing about 1986, and it's the number of problems that have accumulated with it are now legion. I've got a whole signature in the Cell, which I wrote 12 years ago now, had a whole chapter on the multiple problems with the RNA world. But one of them was, the most fundamental one, is an information problem. The whole idea of RNA world was you'd start with a self-replicating RNA molecule that could generate some sort of process of selection prebiotically. But it's emerged that to get any kind of, we've only been able to copy about 10% of the RNA molecule in a lab, to get only about 10% to copy itself. But even then, what's necessary for self-replication is a very specific arrangement of nucleotide bases. In other words, information. So we wanted to invoke prebiotic natural selection in an RNA self-replicating system to explain the origin of information. But even to get that type of self-replication in a molecular system going, you needed a vast amount of pre-existing unexplained information. And I think nature's talking back and saying, you can't build stuff without information. You can't build physical systems without information. And the only source of that is intelligence. And that was actually underscored by the ribozyme engineering experiments that have been done to try to design RNA molecules that can self-replicate, because the sequence of bases necessary to that process was always provided by the ribozyme engineer. In other words, it came from intelligence. And I think process of nature that we need to be open to is the process by which mind imparts information in physical systems. That's part of the reality of the universe. And when we exclude that from our science and we're unwilling to consider that as an explanation, I think we get a very truncated historical biology. We've got a sub-rational view of the universe because we're excluding a cause that we know is in operation, but we're not willing to consider it as an explanation.
I'm not arguing for the RNA world. All I'm saying is that origin of life science is still essentially in its infancy. And there's a lot more that might be discovered along the way. And I think I'm in full agreement with you that there's intelligence behind it. The whole question, however, is, did it occur through process? And at this point, we don't know. We don't know enough about how life existed.
Larry, I think you ask really, really good questions. Thank you. I think it's fascinating, though, is if you look at the trend of the science, because everything in biology, in fact, there's a beautiful article called Frankenstein or Submarine Alkaline Vent, Who's Responsible for Abiogenesis? And this is by Michael Russell, one of the leaders of the field. He talks about how in life, the machinery of life takes chemical reactions out of the hands of physics and chemistry. So everything in life is based on engineering. You have engineering principles that define what life does. And enzymes are molecular machines that constantly force reactions that take place that are against what they would normally do. Either they're too slow or they're thermodynamically unfavorable. And origin of life researchers are saying that basic chemistry and physics will never bring a cell into being. What they always appeal to, though, is natural selection. So they'll say that natural selection basically caused nature to do things that it would never normally do. The obvious problem is you can't have natural selection before you have a fully replicating cell. In fact, even if you bought into the RNA hypothesis, what happens is self-replicating RNAs are always selected for self-replication, nothing else. So again, all of the origin of life research, all that we know about physics and chemistry is pointing to the fact that life represents an engineered system that's forced to do things it would never normally do.
So just as a philosophical point, Larry, of course, we're not making an impossibility proof, but the argument is that intelligent design is an inference to the best explanation based on what we know and based on, as Brian says, the trend line of the direction of origin of life research. Every attempt to explain the origin of information has taken us back to a prior unexplained source of information. And so we're not making progress on that fundamental problem. I think nature's giving us a signal.
My original question was, are you ruling out the possibility that it occurred through process, or was it through an instantaneous phenomenon administered by an intelligent designer?
Well, I rule out the possibility that information can be explained by natural law because the two things are different. But if by process you mean an agent guiding the configuration of matter to a propitious outcome, well, that's part of what that's a form of intelligent design. That's a teleological process. So no, we're not ruling that out, but we're ruling out the in principle incoherency of saying that law and specified complexity are the same thing. They're not. One is not reducible to the other.
I'll go further. I'll say it had to be almost instantaneous, because if you take a cell that's, let's say, 99% to a cell, it's almost perfect. You've got all the information, the genes, the genetic networks. But even if the feedback loops are not properly set, and this is something that systems engineers are realizing, that getting these feedback loops and these integrated control systems to work is not easy. So if you take a cell that's 99% there, but it's not quite there, it can't quite fully function, chemical processes will quickly break that cell back down to simple chemicals. Mm-hmm. At a high energy state, natural processes will push it back to a low energy state. So I would argue that it had to be virtually instantaneous to bring those particles together.
Yeah. So, Walter,
so we're even more radical than we think here, Brian. I didn't realize that.
Yeah, you being in that. Larry, I'd like to comment here a little bit that, Brian, you made quite a bit of interesting comments here. I would just say that a lot of your conclusions are probably not as clear in non-equilibrium thermodynamics. There are clearly areas where you could, in non-equilibrium thermodynamics, where you can achieve the kinds of processes and situations that you said were not possible. That doesn't mean we know what that process is, but I don't see that we can rule that out. But your question, Larry, about process or not process, I think that gets us close a little bit to what Walter and I often talk about, is in terms of whether God did the created life in his normal, customary way of operation, or whether he did some unique, miraculous paths. So, Walter, you want to comment on that? You've told me you don't really have a preference, right?
Well, I probably lean a bit bias-wise toward this system. Well, I'm not sure, Randy. God could have designed it so that it sort of operates to get the outcomes he has in mind, or does he do it as we sometimes do in engineering and just do tinkering as you go?
Mm-hmm.
I don't know. It's a good question, but I'm not sure we know enough to have a good answer. Maybe some of these guys are.
Well, the point I'm trying to make is that I believe we may disagree in some details here, but all of us here agree that God was the creator and created us the life, whether we understand how we did it, whether it's kind of got some unique discontinuities that we haven't acknowledged or whatever. I don't think we should ever allow that to tear us apart or give us agreement here. I think we always want to focus on our unity in the faith here and understanding. And we have some differences, but I like to think that our differences of opinion are methods of deeper understanding. And so, Steve, I think you and I have and continue to have quite differences about information and about abstract kind of relationships, redundancy. I don't find your reasoning compelling. You don't find mine. Okay, that's fine. Let's use this as a brotherly form of how we learn. Let's dig into this deeper and understand a little bit more. But whatever we come out with is not jeopardizing the basic view of creation. Our path is, as said at the beginning, is that it's nominally an hour, and we usually go over it, which we really have. But we do try to end at 3:30 Eastern time, no matter what. But that's for fatigue, as from those who are watching the recording, as well as everything else. But we do have like 3 minutes. Anybody want a final word or final comment? And Walter, you get the last word because you're the feature. But Larry, you want to?
I just want to add.
I wanted the last word.
Yeah, you get the last word, Walter.
We all agree God did it, but how?
Yeah.
Question.
That was actually the comment that I wanted to make. Is that at the end of the day, I think we're trying to figure out how he did it, and that's to me a very interesting question as well. But I think ultimately,
I think that's what excites us about science a lot, right? Most of us got into science because we're really fascinated by the way in which God created the world, both the process and by the way in which He operates it. And I think we all do see God in nature where we look, whether we understand it or not. So I think those are fundamentals. We can get into the weeds here a little bit of what process. I do agree here that if we define life as we understand it today, with the cell and the central dogma, if you will, the core basics, you're not going to get that out of a kind of single thermodynamic leap. I think I would agree on that point. I do think the way Larry expressed it, that we don't know all the processes yet. I do think that there may be ways to study of different understanding of what life is and how it could have created or appeared earlier and over time transformed into what we have today. I don't know how that would work, but I don't think we've ruled those paths out. And maybe someday we'll find out. Probably won't be in my lifetime, but I think the process of understanding all of this is fascinating. Okay, Walter, let me just, Steve, did you have a final comment here?
I just
That's
wanted
good.
to thank
Sure.
you, Randy, for your spirited critique of our book. I think anyone who shares a common interest in these topics creates a basis for friendship, regardless of which
Yes.
side we end up on these things. And also, I just wanted to say, I think for us, the question is not so much, we all agree that God created, but how, rather, we all agree that God created. And for us, the question is, can you tell? Can you detect the evidence of that handiwork in nature? And I think what the intelligent design research community is saying, yeah, you can. There are features of life and the universe that allow you to affirm the activity of a designing hand, and for us as Christians, the designing hand of God.
Mm-hmm.
Yeah, and just want to say thank you for having me. I had a great time.
Yeah, Brian, I'm glad you could join, and thank you for your contribution to this work and everything. So, and with that, it is 3:30, and we like to be punctual if we can. And so I'd like to thank you all for joining, and farewell, and hope to see you next month, December 11, when Peter Bussey will be here, and we can talk more a little bit about divine action and how that might have worked in evolution.